Hi. Now, in this question, we're asked to find the gradient at the point with x-coordinate 2 for each of the following two curves. So, if you'd like to have a go at this and you haven't done so already, just give you a moment to pause the video. And as usual, come back when ready and we'll run through the work solution. Okay, welcome back then if you had a go. Now, to do this first one, y equals 3x all divided by 2x plus 1, because the numerator and the denominator both contain functions of x, it's best done by the quotient rule. You could try it if you wanted by the product rule, that is to do 3x multiplied by all of 2x plus 1 to the power minus 1, but I wouldn't encourage it. So it's the quotient rule. And just to remind you what the quotient rule is, it is this, that if you've got y equals u over v, where u and v are functions of x, then dy by dx equals v multiplied by du by dx minus u times dv dx all over v squared. So for this one then, what we've got is that therefore dy by dx is going to essentially be the denominator multiplied by the differential of the numerator. So we've got the denominator, which is 2x plus 1, and we multiply this by differential of the numerator. So if we differentiate 3x with respect to x, that's going to be 3. And from this we subtract. Okay, now we've got the numerator multiplied by differential of the denominator. So we take the numerator, which is 3x, and we multiply this then by the differential of the denominator. So differentiating 2x plus 1 just gives us 2. And this is all divided by the denominator squared. So we've got 2x plus 1 all squared. Now, let's just tidy this up. If we tidy it up, what we've got, if we expand this bracket out, we've got 6x plus 3. And then we're going to subtract 6x. So all we're left with then is just 3 divided by 2x plus 1 all squared. Now, we've got to find then the gradient at the point with x-coordinate 2, and dy dx gives us the gradient at any point x on the curve. So all we've got to do is just say when x equals 2 and substitute it into here. So when x equals 2, we're going to have the gradient, let's just write it in here, gradient, well that's going to be equal to 3 divided by, well, the denominator here is 2 2's are 4, plus 1 is 5, square it and you've got 25. So you end up with a gradient of 3 over 25. Okay, 3/25 then. Right, now for the next part, okay, part 2, we've got to differentiate y equals the root of 4x squared plus 9. And to do this, we're going to need to use the chain rule. And I'm going to think of this then as y equaling 4x squared plus 9 all to the power half. Okay, when you're to the power half, it's the same as square rooting. So what do I mean by the chain rule? Now you should be familiar with this. Essentially, if you want to find dy by dx, it's the same as doing dy by d something multiplied by the same d something over dx. And that d something I'm going to choose as dt. Okay? It's as if these two dt's cancel and you're left with dy over dx. Now, that is called the chain rule, so we'll just highlight that, okay, by putting a box around it. So if I let t be 4x squared plus 9, I've got y equals t to the power half. So we'll just say let y equal t to the power half, where t, okay, equals 4x squared plus 9. So when it comes to differentiating this here, okay, using the chain rule, dy by dx, okay, put therefore dy by dx equals dy by dt first of all. Well, y equals t to the power half, so if you differentiate that, you're going to get a half t to the power minus a half. Half then, t being 4x squared plus 9, okay, and it's now to the power minus a half. So that's dy by dt. dy dt then equals a half t to the power minus a half. Half t to the power minus a half. And then I need to multiply it by dt by dx. So if I differentiate t with respect to x, this term is 8x, and this goes to 0. So we're just left with 8x there. Now I just need to clean this up, and I can see that this 2 will cancel into the 8 4 times. So I'm left here with 4x. 4x multiplied by 4x squared plus 9 to the minus a half. If I tidy that up, I end up with 4x multiplied by 1 over 4x squared plus 9 to the power half, which reduces to 4x over 4x squared plus 9 to the power a half. So that when I now substitute x equals 2 in, I get that gradient. So when x equals 2, what I have is that the gradient, okay, is going to equal 4 times x, which is 2. 4 2's are 8. And then this is divided by, and if I put 2 in for the x here, square it, I got 4. 4 4's are 16, plus 9 is 25. And so I've got the square root of 25, which is going to be 5. We won't worry about the plus or minus, okay, when we root it. We'll just take the positive value. So we've got a gradient of 8/5. All right?